Today we're going to talk about perimeter and area. In the case of a circle, we call its perimeter the circumference. The area of a closed figure is the area inside the perimeter. So let's use this yellow highlighter and we are going to color inside the blue boundary. I'm trying to keep it inside. And here we go. So this shaded yellow area is the area of this rectangle. And how do we know it's a rectangle? Let's make sure we mark that. Rectangle has 4 right angles. And the property of this rectangle is opposite sides are congruent. A parallelogram is basically a tilted rectangle. And in this case as well, the area is base times height. So this is the base. And what's noteworthy is that the height goes from one vertex to the opposite base and it makes a right angle with the opposite base. So this is the height, and actually there is more than one height here. So from this vertex I can go over there, and that's also a height. Now similarly, I could start at this vertex here and then draw a right angle segment to the opposite side, etc. So base times height is the area of a parallelogram. A triangle is half of a parallelogram. So base times height divided by 2. So let's look at the triangle A, B, C in this case. And the base would be, could be any one of the sides. So let's choose this side. Let's say that's the base. So the height in that case is going to be so the height goes from vertex C to base B and makes a right angle. This is the height, this is the base. You notice that in this case the height of the triangle, which is also called the altitude, is inside triangle ABC. This is not always the case, as you will see in these figures. In the acute triangle over here, and we call it acute because all the angles are less than 90 degrees, the height will be inside the triangle. So let's take, just for fun, I'm going to use a vertex that's not a conventional one, but you can use any one of, so this, there we go. This is the height, and in this case this is the base. The base is the one that the height makes a right angle with. Now let's look at this obtuse triangle. This is the obtuse angle. It's more than 90 degrees. And let's say I want to use, this is the base. If I try and draw a perpendicular from the opposite vertex, you will notice that it falls outside the triangle, and that is a-okay. All you do is you extend the base. The highlighted base is in blue, so we would only use that measure, and this is the height which falls outside the triangle. So let's go ahead and highlight that in blue. Also, that tells us that we want to use that height and this base only, the one in blue, to find the area. Okay. Now if I could just get rid of this clock, that would be very nice. So let's try it here. And again. All right. This triangle on the right is a right triangle, and it is right because I've indicated that it's a right. In a right triangle, the longest side is called the hypotenuse. The other two sides are called legs. So let's try this. Okay, the two highlight sides are legs, so this is a leg and this is a leg. Now, to find the area of this triangle, it doesn't matter which leg you call the base and which leg you call the height. Just take your pick. One's the base and one is the height. This does not mean that you cannot find the area of a right triangle if you were given the hypotenuse. If you were given the hypotenuse, this is what you would do. You use this base, and I am going to draw the height this way. So you could do that also. Now we come to a circle. The perimeter of a circle, which is the boundary, the round part. Let's say if this was a bangle that you're wearing, what would its length be? Its length would be 2 pi r, and when you want to use pi on your calculator, use the pi button. Do not use the approximation. And the area inside is pi r squared. Okay, now I want you to answer the following questions. Okay. You can read those yourself and answer the questions.